Okay, so here's phase 6. There's only one more phase, and then we're done for the year, and then I'll start doing like free response videos. So I found this. So we're talking about something called the net change theorem. So let me go net change theorem, which basically says this. So I got this off of so I just searched net change in math because I wanted some words to describe it. It's kind of self-explanatory, I think. So net change means like the okay, so let's say this. Like if today I have $20 and then tomorrow I have $30, my net change in dollars is 10. Okay, so it's just like my net change in dollars from today to tomorrow is 10. So yeah. So anyway, so what it basically means, so let me look here first. So f of b minus f of a is the net change in f of x from a to b. Okay, so it's like, in my case that I just talked about, I think I said I had $30 and I had $40. So it'd be 40 minus 30, which would be 10. And guys, this here, so if we knew the rate of change of f and we put it in an integral, that'd be the same as doing f of b minus f of a, because that's the fundamental theorem of calculus. So that's the fundamental theorem of calculus. So basically, if we know that f prime of x is the rate of change of f, then the integral of the rate of change from a to b is equal to the net change of f of x from a to b. And this is, so this perspective on the fundamental theorem of calculus is very helpful when you're doing word problems. So, here's the website, or here's the, what is this called? The link, I guess. There's the link to the video where I screenshotted this off of. Okay, brightstorm.com was the guy. I just Googled net change and it came up. And then I liked how he laid that out. All right, so here I'm giving some examples of rates of change. And then over here, we're going to use the net change theorem to express the net change using an integral. So let's say that m of t is the rate at which the amount of money in a bank account is changing in dollars per day. Okay, so dollars per day. And now I want to use an integral for this net change. So the net change in this context that I'm looking for would be the amount of money gained or lost from day 7 to day 15. All right, so the integral from 7 to 15, and then you put the rate of change in here. So that'd be m of t dt. And then this is going to give me, the amount of money. Okay, so the rate has units like something per something, but then when you do the net change, you're just going to get like the top unit. So this would just be dollars. So, yeah, now let's do this one. So B of t, I'm going to have that represent the rate at which the amount of water in a tank is changing in gallons per minute. So the net change I want is the amount of water gained or lost from 0 to 10 minutes. So 0 to 10. And then if I want that net change, I put the rate of change in there. Okay, so integral of a rate of change gives net change. All right, and so this was gallons per minute is the rate, so this is just going to be gallons. And now let's do this one. So let's let capital T of T be the temperature of a cooling cup of coffee in degrees per minute. So the net change I want is the change in temperature of the coffee from 5 to 6 minutes. So I go 5 to 6. And if I want the net change in here, I put the rate of change. And that will give me a certain amount of degrees. Okay, now, when we're doing the word problems that are on the following pages, there's really going to be 4 scenarios of information that we're given. So let me talk about that. So I'm letting A of 0 be the initial amount. I'm letting AI be the amount that has gone in. I am letting AO be the amount that has come out. RI is the rate at which something is going in. RO is the rate at which something is coming out. And what I noticed when I was doing some of these problems to get ready for teaching this is that here's basically the 4 cases of, so the given information is usually presented in one of these 4 combinations. Initial amount, amount that has gone in, amount that has come out. Initial amount, the rate at which something is going in, and the rate at which something is coming out. Initial amount again for these, but then with the rate at which something is going in and the amount that has come out, or the the amount that has gone in and then the rate at which something is coming out. All right, and to do these problems, it helps you to consider which of these cases you're dealing with, and I will show you how. Alrighty. So a tank has 300 liters of water in it at time t equals 0 minutes. And guys, as you're reading these, you want to be labeling. If you come across an initial amount, an amount in, out, a rate in, or a rate out, you want to label as one of these things. All right, so a tank has 300 liters of water in it at time t equals 0 minutes. Excuse me. Water begins to be pumped into the tank at t equals 0, and then a different pipe is draining water from the tank, also starting at t equals 0. Guys, this 300 liters of water in it at time t equals 0 minutes, that's the initial amount. So they're telling us right there that. Okay, now, water is being pumped into the tank at a rate modeled by the function k of t, where k of t is measured in liters per minute. Okay, so k of t, what is that? That is a rate in. Okay, because they said that that was a rate. That's the rate at which water is being pumped in. So this is the rate at which water is going in. Now here, the total amount of water in liters that has been removed, from the tank t minutes after the pump was turned on, can be modeled by this function b of t. Now, guys, b of t is not a rate. This is the amount that has gone out. All right. So what is the total amount of water in the tank at time t equals 7? So that's what we want, the total amount of water in the tank at t equals 7. You may use a calculator and round to the nearest thousandth. Use proper units and show how you got your answer. Okay, so let me consider what I have. Oh, and guys, when you're doing like one of these out things, you're subtracting these out things. So I put the in things first, like when I'm a rate machine. So initial amount, in, out. Initial amount, in, out. So let me think of what I have. So this is what I have. The things I have are the initial amount, and then I've got the rate in, and then I've got the amount that has come out. Functions for each of these things at certain times. But I want the total amount of water in the tank at t equals 7. So what I want is to take the initial amount, add to it the amount that has gone in, and then I want to subtract from it the amount that has gone out. Okay, so this is what I want. This is the stuff that I have. This is what I want. So now I need to take what I have and use it to get what I want. So guys, these, I have a of 0 and I want it there. I have a function that will give me the amount that's gone out at any time, and I want the amount that has come out, that has gone out at 7. And so this is the only difference. I have the rate at which water is being pumped in, and I want the amount of water that has been pumped in at t equals 7. So guys, how do I relate these two things? From the net change theorem, okay? If you've got a rate and you want the amount of change, you do the integral, all right? So, anyway, yeah. So A of 0 is 300 plus, if I want the total amount that has gone in from 0, so I want the amount that has gone in at 7, what are these? Seconds? Minutes. 7 minutes. If I want the amount has gone in at 7 minutes, then I've got to do the integral from 0 to 7 of k of t dt. Okay, so relate it to these things. Okay, so if k of t is the rate at which, we've got the water being pumped in, then the integral, and we want the amount of water gained from 0 to 7, then it's just very similar to these guys. Okay, if you don't see the similarities, then pause the video and see how this relates to what I talked about at the beginning. And then we're going to subtract the amount that has gone out at 7. So that would be B at 7. All right, now the beautiful thing, guys, is you could do this all in your calculator. Now let me write down, okay, so this is optional to write, but it's going to be 300 plus from 0 to 7. So K of T is 10, 0, negative 10. And then minus, okay, B of 7 is going to be negative 39 to the 7th plus 39. Okay, now I said this was optional to write down because you can go directly to your calculator from here. All right, as long as this is written down, you're just fine, guys. Your reader is going to know exactly what you're talking about because K and B were defined for you above. All right, it might be helpful. I think if I were you on the test, I would write this line out just so I'm super, super careful with what I plug in to my calculator. Like I have it right in front of me, what I'm plugging in. I don't have to keep looking up. All right, math 9. If you wanted a derivative, it'd be math 8. To the x minus to the 7th. Okay, nearest thousandth they want. So this is 282.400, 3 decimal places. And then they also want good units, so this is liters. All right, I'm going to do 2 more examples, guys. Oh, sorry about that. All right, so here's number 2. A tank has 100 gallons of water in it at time t equals 0 hours. All right, so that's going to be our initial amount. The amount at 0 is 100. And guys, I'm using amount up here like with function notation, like A at 0. If they also used A to represent like a function with function notation, if they used A somewhere, maybe you should write out like amount at 0 or something like if they are using A as a function in the problem, then when you're using A to represent just amount, do like AMT. All right. Otherwise, it's going to look like your A and their A would be different. Okay, so a tank has 100 gallons of water in it at time t equals 0 hours. Water begins to be pumped into the tank at t equals 0. A different pipe is draining water from the tank starting at that. Okay, same like initial situation. The total amount of water in gallons that has been removed from the tank t hours after the pump was turned on can be modeled by this function. This is not a rate. This is the total amount of water. So this is the amount. This function gives us the amount that has gone out. right? The amount that has gone out, the amount that has been removed. Okay, water is being pumped into the tank at a rate modeled by this function, where C of T is measured in gallons per hour. So that's just gallons. This is gallons per hour. The units also, guys, are a clue for whether it's a rate or not, because a rate will always be something per something. So this is the rate in. Okay, so what is the total change? What is the total change in the amount of water in the tank from T equals 0 to T equals 23? All right, so let me lay out what I've got. Remember, the ins come first, so it goes initial, ins, outs. All right, so what I have is, I have A of 0, I have the rate in, and I have the amount that's going out. Basically, same situation as before. All right, now let me think about what I want. The total change in the amount of water in the tank from T equals 0 to T equals 23. So I want to do this. I want to do, if I want the total change in the amount of water, I want to do the amount at T equals 23 minus the amount at T equals 0. All right, I got to get this change in the amounts. Okay, change is subtraction. Now, how am I going to do the amount at T equals 23? Well, the amount at T equals 23, and I want to be thinking of how I'm going to use these things. The amount at T equals 23, that's going to be the amount, the initial amount, plus the amount that has gone in minus the amount that has gone out, right? Minus the amount at T equals 0. Oh, that's the initial amount right there. The amount at T equals 0, that's the initial amount. So that would actually, that'd be the initial amount again. So, oh yeah, so if you look at this, guys, if the way you're figuring this, you don't even actually need the initial amounts, they're both 100. All right, so you're going to have like 100 here and you're going to have 100 there. So those are going to end up canceling. So really what we want is the amount that has gone in minus the amount that has come out. And that is going to give us the total change in the amount of water. Okay. So I already have a function for the amount that has come out. So I've got that right there. But just like before, I have the rate at which water is being pumped in, but I want the amount of water that has been pumped in from 0 to 23. So I got to do an integral to get from here to here. The integral of this is going to give me that. Right? Integral of this, the integral of the rate will give me the net change. So I'm going to do the integral from 0 to 23. And then in here, I got to put this rate in, which is C of T, minus the amount that has come out at 23. All right, the amount that has come out at 23, that's what I want for that part. Okay, so this is from 0 to 23. And like I said before, guys, you can go directly to your calculator. But to be honest, when I do that, I make mistakes. So if I were you on the AP test, I'd write in a line. I would write down a line of exactly what I'm plugging in my calculator. But that is just me. I know you guys, and I know some of you are not going to feel the need to do that, and you don't have to. To the 23rd. Okay. Yeah, so that's what I'm plugging into my calculator. So I go math 9, 0 to 23. Yeah, when I did this earlier, I left out the decimal because I was just looking up, and I feel like if I had written it down, I wouldn't have made that mistake. Negative 294.96 to the 23rd. 294. Oh, wait, did I do that right? Yeah, I did. Okay. So 10.864 gallons. Alrighty. I know this is kind of long, guys, but I'm just going to do one more. I'll only put into Delta Math that you're required to do 3 of these, but do as much as you can, guys. This is the closest. There very likely could be this. I would bet that this type of concept will be on your test. Rate in, rate out is very popular. Okay. A tank has 250 gallons of water in it at time equals, it's all about water, huh? It's not always water on the test, but water is a good, it's a good, I guess, model for other things, changing water. Okay, so we got the amount at 0 is 250. All right, and I'm safe to use A in function notation because there's no other function that they're calling A. Water begins to be pumped into the tank there. Different pipe draining, so same situation. Water is being pumped into the tank at a rate modeled by this function, so that's the rate in, all right, gallons per hour. The total amount of water in gallons that has been removed from the tank T hours after the pump was turned on can be modeled by this function. So this is the amount that's gone out. I'm sort of disappointed that all of our examples have been of number 3 form, but they could be any of these 4 forms. Pumped into the tank, blah, blah, blah. All right, so I want, what is the total amount of water that has been pumped into the tank from time 0 to 6? All right, so let me lay out what I've got. I've got this initial amount. I've got the rate at which water is being pumped in, and I've got the amount that has come out. And now what do I want? What is the total amount of water that has been pumped into the tank from 0 to 6? So I want the amount that has been pumped in. So guys, I really don't even need this initial amount and the amount that has come out. Those 2 things don't matter about, they're just asking what is the total amount of water that has been pumped in. So this is what I want. I've got this rate. This is exactly a net change situation. I've got this rate of change. I want the net change in water from 0 to 6. So I'm just going to do the integral of this to get me that. So I'm just going to go the integral from 0 to 6. All right, the integral of the rate is going to give you the net change. And in this case, that net change means the amount of water that has been pumped in. And then f of t. So this is 0 to 6. Okay. And then you just use Math 9. Math 9. 0 to 6. Okay, 66.294. Units, gallons. Okay, yeah, maybe these are all about water. All right, when I start doing AP problems, like videos for AP problems, I'll find ones like this that involve things other than water. And another thing, guys, that could be different is here we have water begins to be pumped into the tank at T equals 0, but a lot of times in the AP exam, and I will find an example for you, a different pipe is draining water from the tank starting at maybe T equals 5. So from like 0 to 5, water is just being pumped in, and then starting at 5 hours in this case, water would be going in and coming out. So that is a common situation. And what it does is it would change the endpoints on the integral and would change like how many integrals you would need to use. So I'll find some like that. I'm going to put in that you need to do 3 of these problems. And but please do more if you want. These are fun when you get the hang of them. Very satisfying when you get them right. And if you are stuck on a problem on Delta Math, I selected the option where they provide videos for you, so you could watch a help video. You could also take a picture of the problem. You and I can't hop on Delta Math at the same time and see the same problem, but you could take a picture of your problem, text it to me. I will right away help you immediately. All right, guys, I will talk to you later. Bye-bye.